So you made it to the second video, the second part of notes, the back of the front page. On the front of notes, we learned that the midsegment theorem says that the midsegment is parallel to the third side and half as long. We learned that about the midsegment, that it's parallel to the third side and half as long. We're told for the three examples right here that DE is midsegment of triangle ABC. We have to find the value of x using the midsegment theorem. So, once we find the value of x, we also need to write the parallel and congruency statements. We're not going to do it in that order, but we'll write parallel and congruency statements. One thing I want to review is what is a midsegment. It's the segment that connects two midpoints. So if the midsegment is a segment that connects two midpoints, then we know that D is a midpoint. It's the midpoint of AB. We can show that it's the midpoint by putting tick marks on either side. Here, E is the midpoint of BC. We can show that it's the midpoint by putting tick marks on each side, 2 tick marks on each side. So all we've done thus far is just interpret the definition of a midsegment. Now let's apply this theorem. It's parallel to the third side. So DE, that midsegment, is parallel to AC, the third side. Also, it's half as long. So DE is half as long as the third side, AC. We talked about if it's half as long, that means that we can double it. So 2 times DE will equal AC. So let's solve for x. If x is half as long as AC, that means 2 times our x equals 34. You have to think about what times 2 equals 34. Well, it would be 17. X equals 17. Now let's apply this theorem again for the next problem. DE is still our midsegment. So DE is our midsegment. T is the midpoint of BC. We can show that D is the midpoint by putting tick marks on either side. If DE is our midsegment, then E is the midpoint of AC. We're going to show that E is a midpoint by putting 2 tick marks on either side. So our theorem tells us that this midsegment, DE, is parallel to the third side. In this triangle, the third side is AB. Remember, we can show that 2 segments or lines are parallel by putting arrows on them. So, it's parallel, and also the midsegment, DE, is half as long as that third side, AB. The opposite of having the inverse operation is to double something. So 2 times our midsegment will equal our third side, AB. So we have all of these statements and we need to solve for x. Well, 2 times DE, well, DE is 7 units long, will give us X. So, using that logic, X is 14. So we get to our last problem. DE is still a midsegment. So we know that D is the midpoint of AB and E is the midpoint of AC. DE is parallel to BC. DE, that midsegment, is half as long as the third side, BC. Also, if it's half as long as the third side, we can double the midsegment to get the third side, BC. And we know that all this information, but what we're going to use to solve for X is simply the definition of a midsegment. If E is the midsegment and E is the midpoint, then it splits AC into two congruent pieces. All we have to ask ourselves is, what is X marked congruent to? Well, over here with 2 tick marks is 8. X is marked congruent to the segment with 2 tick marks. So X is 8 units long. Now, let's take a look at the diagram below. Use a diagram of triangle ABC where D, E, F are midpoints of the sides. Well, D is a midpoint, E is a midpoint, and F are midpoints. We can put tick marks accordingly. That would mean that DE is a midsegment, EF is a midsegment, and FD is a midsegment. Those are all midsegments. Now, what midsegment are we most interested in? Well, we're told that FE is 6.5x minus 10. We're told that AB is 3x plus 20. We need to solve for x. Before we solve for x, let's recall our properties. If we have a midsegment, our midsegment of interest is EF. We know from our theorem that EF is parallel to the third side. So EF is parallel to BA. Also, EF is half as long as BA. And lastly, if we don't want to deal with the fraction, we can simply double our midsegment. Double the midsegment equals the third side. Again, this is what I'm going to use to solve problems. So if I set this up, 2 times EF, what is the measure of EF? We're told that EF is 6.5x minus 10 will equal that third side, BA or AB, 3x plus 20. So we've set it up using this property, using the theorem. Now that we've set it up, let's go ahead and solve for x. I have to distribute that 2. When we distribute the 2, we end up with 13x minus 20 equals 3x plus 20. 10x minus 20 equals 20. 10x equals 40. And x equals 4. Now we found x, and that's all handy dandy, but does our problem ask us to find x? No, it does not. It asks us to find AB. So what we're going to do is for this segment AB, we are going to plug in 4 for x. So 3 times 4 plus 20 equals AB. So 12 plus 20 is 32 equals AB. AB equals 32 units. Let's write our summary. Our summary is this. A mid-segment of a line, of a triangle, is a line segment that connects the midpoints of two sides. That's what a midsegment is. Now, what are its properties? Well, the midsegment theorem states that the midsegment is parallel to the third side and half as long. Again, summarizing our notes, we learned that a midsegment of a triangle is a line segment that connects the midpoints of two sides. The midsegment theorem states that the midsegment is parallel to the third side and half as long. Let's learn about exterior angles in the next video.